Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, January daily challenge, nth Tribonacci number, problem 1137. So what the problem says is basically we have a Tribonacci sequence Tn, which is sort of similar to Fibonacci's sequence, except Fibonacci sequence is of course just the sum of two values. Here it's the sum of three values. And basically the definition is that T0 is 0, T1 and T2 are equal to 1, and Tn plus 3 is the sum of Tn plus 1, and Tn plus 2, right? And basically we want to return the value of Tn for a given n value, right? So that's pretty straightforward. So the first easiest solution is just to do recursion, right? And so if you do recursion, then the solution becomes pretty straightforward. So let's just grab our formula first here so that we can have it handy. And what we want to do is have this like this, okay? And what we want to do is just define our recursive function. So that would be the easiest approach, and we'll just pass it maybe some value I, right? And what we want to do is we have the definition here, so we can just apply it, right? So if x is equal to 0, then we want to return 0. Now if x is either 1 or 2, so in that case we can just do in 1, 2. Then we want to return 1. So that's the definition here. Now we apply this. But since this is a recursion that we want to go from the tab value and keep reducing, then what we can do here is just call recursive function on, suppose this was written in terms of Tn, then Tn would be equal to Tn minus 3 plus Tn minus 2 plus Tn minus 1, right? This is actually this is equivalent to this, except we are writing it in terms of Tn instead of Tn plus 3. So you can see from this here, Tn plus 3 is just the sum of the three previous values, and that's exactly what we are doing here. And so that's what we'll do here. So this is actually I, and then here we just want to do exactly this. So let's just convert this to recursion. So this would be recursion on I minus 3 plus recursion on I minus 2 and the recursion on I minus 1, okay? And that should be it. Now we are going to call recursion starting from n and let it go down all the way to the end, okay? But for a specific value, we might end up calling this function multiple times, right? And so we want to cache a value that we've calculated before so that each time we don't recalculate. So if this function, let's say, gets called maybe a recursion of 5, gets called the first time, and then because of I minus 2, so this can be called from 6, but it can also be called from 7 with I minus 2. And so it can also, so it will be called 2 times. We don't want to calculate it 2 times, go all the way to 1 and calculate it 2 times. So we want to cache the value. And so to do that, we'll just start with memo cache, and so here we'll check if I is in memo. We'll return memo of I, and before assigning, so before returning we want to assign it, and that should be it for a cache. So let's submit, and that passes, okay? Now another thing we can do here, again, I mentioned this often in caching solutions. It's just to cache using Python annotation, and so you can do that with just this, and that would accomplish the exact same thing, and it's quicker to write, so that works as well. Okay, so this was the recursive function. It's sort of dynamic programming, so how can we actually just apply dynamic programming instead of doing the recursion? So we have a couple of ways of doing this. So the first way is to just define our DP. So let's remove this DP array for dynamic programming. What would be the recurrence relation? I find it, by the way, for problems that are really simple, it's really good to apply things like dynamic programming just so that you can really understand it, okay? So what would be the recurrence relation? Well, it's exactly what we have here, except we want to replace it with a DP array, right? So what this tells us is basically that DP of, let's say, I plus 3 is going to be just DP of I from this here. So we are just replacing n with I, DP of I plus 1, and here DP of I plus 2, right? And so we can exactly apply that. And what would be the base cases? Well, we already have our base cases here. So that means basically dp of 0 is equal to 0. And dp of 1 is equal to 1, and dp of 2 is equal to 2, right? So we already have almost all of this already laid out, so we can just use it. We'll just initialize our dp array to zeros. Now the question becomes, how many entries do we need? Well, we want to, at the end, we want to return dp of n, right? So that means in Python we need to go to n plus 1, so that the last one is at index n. And so at the end we want to return dp of n. And now what we need to do is just go through, initialize our, what we said here, right? So we don't need the first one because the values are already initialized to 0, so we can just skip that. But for dp of 1 and dp of 2, we need these two here. We need to initialize them to 1. And now we can just start doing our dp relations. So we will apply this. Now the question becomes, what do we need here? So you can see already, because we are doing I plus 3, that means so that we don't exceed like the limit of this dp array, we need to do n minus 2 because because the last value we want to calculate is just dp of n, right? And n minus 2, right? If you add 3, that will give you n plus 1. That's exactly where we want to stop, okay? And so that's why we have n minus 2 here. And then we just apply the exact recurrence relation that we had from here. Then at the end we return dp of n. And let's submit this one. Okay, so it looks like we have an error here because this is probably because of an input, because n equal to 0. So how do we solve that? So the easiest way to solve for that is just here, just to make sure we don't, if n equal to 0, we'll just have one entry. So we can just say either 2 or n plus 1. This is just so that this here never fails, right? And for n equal to 0, we'll end up returning dp of 0, which will return 0. So it's the correct result, okay? So if we run this, submit. Okay, sorry about that. So yeah, this needs to be plus 1 here, right? Because Python, the last element needs to be, it needs to add plus 1 to get that exact value, okay? So if we run this, submit, it should work fine, and that works. Okay, so you can see here, this is a lot easier. Now, in terms of time complexity, this is O of n time. In terms of space, we are using this dp array, so O of n space. Yeah, so the question becomes, can we improve some of this? Can we improve at least the space? And the answer is yes, actually, because you can see here, for each value, we are using only the 3 previous values, okay? So let's just use those previous values, right? But before that, I want to make a small change. So I want to make this go from n, so that I want to use something similar to what we did for the initial recursive function. So this here would be minus 3, and this one minus 2, and this one minus 1. So still we are only using the 3 previous values. And here, just to get to dp of n, we need this to be plus 1. And looks like there is a small problem here because we already actually did 2 here, right? We already did initialize 2, so only we need from 3 to n plus 1. And that looks good. Let's submit. And that still passes. Okay, so now can we get rid of this array? We shouldn't need it. So actually, yes. Let's replace this with a, b, c. And let's assume that a is going to be dp of what we have here as dp of I. And then b is going to be dp of so this one basically is going to be the current one. And this one, let's actually call them this. So current, prev, and before prev. So just the one before prev, right? So those are what we are going to use here. So let's call it current prev, and before prev. Okay. And so this would be, what should be current? So we want them to be 110, right? So we want them to be representing from 0 to 2. So we can just do that. So get rid of this. And we want to maintain the same thing we are doing here. Now what we want to return is current, because that's the last value. And this should be the current value. What should be this? Well, this is I minus 3, so it's the before previous. And this is I minus 2, so it's previous. And this is just the previous, the one that was current before, the iteration before. So this one should be current. Okay? And that should be it. Looks like there is one problem, which is we are doing more than we need to. Yeah, so we filled current, but we should fill prev and before prev for the next iteration, right? So what does prev become? I'm intentionally doing this here because otherwise we will get the overridden value of current, okay? And so what does prev become and what does before prev become? So prev is just the one that was current before. And what is before prev is just the previous value, right? Okay, and that should be it. Let's try it. And that looks good. Let's submit. Okay, yep. So we have one case here which is n equal to 0, and that's because we return current, which will be equal to 1. So here we just need to safeguard against that and say if n equal to 0, we want to return 0. And we can submit, and that passes. Okay. Okay, so now in the spirit of gradually improving, actually first, in terms of time complexity, now we are at O of 1 space and O of n time. But this check is a little bit ugly. So how can we resolve it? So we can resolve it by making this calculation here. Just calculates, we need at least one value so that we get something incremented, because if we have only zeros, then that would be a problem. So what we can do is make this basically be just for prev would be for n equal to 0, and current would be for n equal to 1. So that would be initialization here, and before prev is just the default initialization value. So what this means is that here we want to start from 1 because we already calculated for the other 2. So 2 to n plus 2. And so now that we are doing 2 to n plus 2, we need to return prev because this will stop at n plus 1. Okay? So current would be for n plus 1. And so to get for the value at n, we just need to return current, right? Sorry, we just need to return prev because so prev would be for n. And this works because it will also return 0 for n equal to 0 because prev is for n equal to 0. So for n equal to 0, we will not enter here. And so that would allow us to solve for n equal to 0. I hope this trick was clear. And that should be it, I think. So let's run it. Looks good. Let's submit. And that passes our test cases. And this is still O of 1 time and O of 1 space. And without any extra checks here. Yeah, so that's pretty much it for this problem. I think it's, even though it's an easy problem, it's a good application of dynamic programming and the different ways to do dynamic programming. Yeah, please like and subscribe, and see you on the next one.